Hello everyone. In this video, we will go over on how to create an online database on Azure. So the first step is that you will need to create an Azure account. So once you create an account, you will receive $200 credit. In this step, it is important or it's recommended that you use a prepaid or rechargeable credit card so you avoid unexpected fees. However, typically once you consume the $200, unless you change the account, there is like a status like pay as you go. So if you don't make that change, then you won't be charged. But just be careful. All right. So assuming that you have created your account, let's continue. So you sign in using your new account. Now we will create an Azure database for Postgresql. So in my case, it's here available because I have been using it. So I'm using Azure Database for PostgreSQL Flexible Server. But if you don't see it, you can just type here Postgres. So you will see all the options, right? So here, the second one, Azure Database for PostgreSQL Flexible Servers. So that's the one that we're using. So I have three of them right now. We're going to use Big Data SP. That's the one we're going to use. But it takes time. I mean, the configuration is simple, but it takes around 5 minutes to be available. So that's why I'm using this one later. Okay, so let's go over the steps. So now I can create a new database. So first we need to provide basic information. Okay, so for the project detail, the subscription. So I just have this Azure subscription one. Resource group, in your case, is going to be empty. So this is useful. You should create new. So why this is useful? Because remember that sometimes you can create or use different services here. Like for example, in creating a database, but later I will create a dashboard to use that database, and maybe you're using a script to feed the database. So you have like different services, right? But if you use the same research group, so you can shut everything down at the same time. So it's very useful to create a group. In my case, I created one. Just call it Big Data. Again, you will need to create a new resource group, and it's just a way to label different services that you're using under the same umbrella. All right. So then you need to provide server information. So let's create a server name. So I have been using Big Data. So let's use Big Data server, something like that. Let's see if it's available. Oh, like this. This one is available, Big Data Server. So be careful just with the symbols. Then you need to define the region. So in my specific case, I'm not allowed to create, to spend the free credits on the East US. So you can change it, right? I'm going to pick a different region in the US. So in my case, it's working with the Central US. Now, for the class purposes, this is not that big, it's not that important, but in real life, for the real application, it matters because it's the availability will be given by the region. It means like how fast it's gonna communicate, your server with your needs. So it's important to pick a region that is close to you. Okay, so let's use the latest version of Postgres 17. So this is important. The workload type. Please notice that right now the estimated total is $620. Please don't be scared, right? So in our case, we don't need production because we're not gonna use this, for a company. It's most for academic purposes. So development is fine. So we don't need advanced resources for that. So now, please note that the total decreased. Like we divided by 10. So instead of 600, now it's 60. But of course, we'll keep reducing that amount of value. because we don't need that much, of the resources. Then we have the compute and storage. So the number of cores, RAM, and the storage. So let's configure the server. So let's pick something basic. So here in the compute size, I'm going to pick the lowest one, standard B1. So it's just one core, 2 gigabytes of RAM. So this is the cheapest configuration. I'm sorry, be careful. Yes, this is the cheapest configuration. And now, please notice that here it's $18, but we get some, it said like free up to 750 hours. That's for the compute. And then for the storage, it's free up to 32 gigabytes. We won't use the 32 gigabytes in our applications. Okay, so once we have defined this, we can keep everything else as it is. I think we're in the minimum of everything. So we save. Okay, and we continue with the networking. All right, so we allow public access. And here, this is important. So we want to add our IP. This is important because when you add your IP, it means that you can, from your computer, from your local computer, you can access the database. So now our IP, that's my IP, it's allowed. So I can connect from my laptop. Now, this is not secure what I'm going to do, but I just want to show you, like, for example, for this class, if I want you to, I want to give you the possibility to connect to the database that I'm creating. So you can create a range here. You get like a warning message, like be careful because I'm adding a range, for multiple IPs. Like anyone can get into this database. So that's why I'm saying this is not safe. But again, this is not an important database with sensitive data. That's why it's okay. I'm allowing to the multiple IPs. All right, so now I can connect from my personal computer, and you know how to you can allow multiple users if safety is not an issue, like for academic purposes. All right, this is also an important option if you want to allow public access from any Azure service within Azure to this server. Yes, let's check this because sometimes if you create, or you've used other services from Azure that will use this database, so you want, like access for that. So I'm allowing that. So security, I'm not changing security. I'm not adding tags. I'm just, like with the basic configuration so we can move forward. Okay, we're missing something. Let's see what we're missing. Oh, I forgot something really important. How to connect to the server. Here, of course, you need to define a login. I'm going to use just the Postgresql authentication only. It's faster. So the administration login. So that's, any name you want to use as your username to connect to the server. So it's going to do it like test123. You need to provide a password. So you need, the rules. There you go. Confirm the password. All right. So we have created the server name. Now the user that is you need to remember, of course, this information. Be careful. This is relevant. Now, since I'm going to use a different server that I created before this video, I'm not using the test123. I already have a different login. But again, for you, since you are creating this on your own, so just please be careful to remember the password and the login information. All right, so let's review and create. I think we're ready to go. So now we can hit create. And again, it will take around 5 minutes to complete, like all the setup of this server in where we're going to create some databases. So the deployment is in progress, right? The big data server. I'm not going to wait, like the 5 minutes. So let's continue. Again, I'm going to use a previous server that I have loaded. Now for that server, it's important the connection, right? So this is how we're going to connect from our local computer. So using PSQL, that's what we're going to write on our terminal. Then we have this information. So the host is going to be, this is the server name. So this is going to change, right? That will depend of the name of the server that you're creating. The one that I created previously is big data sp, and this is going to remain the same, postgres.database.azure.com. The port we're using the default port 5432. The database name, we're using the default database. We can create more databases later. And this is my username, Daniel H. Romero, my name. The password, it's okay. This is a toy dataset, a toy database. So this is my password, and SSL mode is equal to require. So with this command, we can connect to the existing server big data sp. So the idea is that you should do the same with the server that you're just creating once it's done, So let's go to Visual Studio Code. So in Visual Studio Code, I'm going to open the folder where I have, all the scripts that I'm going to use to add information into my database. So I'm going to open the folder. It's database on Azure, this one. So once you open the folder, you will see some scripts here, some SQL files that I will be using later to load information into the database. All right. So we connect with the PSQL again, and the information of the server and the user. So once we're here, we can start creating some databases. So for example, I'm going to create a new database. I'm going to call it create database. That's the command. The name of the database, I'm going to call it streamdb. So this database is going to be for, there are some devices in different locations, and they are recording some measurements, and we're getting that information stored into our database. Okay, so create database, streamdb, that's the name that I'm assigning to the database. So it was created. You can see the list of the database. The command is \l. It will show me the list. So we have the Postgres, right? And we have the streamdb. There are some other databases. You can keep going in the table, or if you want to stop it here, you don't want to see like more information for that query, you can just hit Ctrl+C, and you are back to Postgres, to the Postgres database, like this. Now you can move to the new database that we just created, and we want to add some information to our new database. So let's connect. So we use the \C, that's to connect to a different database, and you need to provide just the name of the database, which is streamdb. Okay, so now we're connected to the streamdb as user Daniel H. Romero. I will give you a list of commands for PSQL, right, which are useful. So far, I'm using this one to list the databases, to connect to the database. So there are different commands to visualize the tables. When you want to run a script, this one is really important. We're going to use it right now, the I, like \I, and the name of the SQL file. That one is really useful. Or for example, the connection info, con info. Let's use that one. call info. So it will tell you that you're connected to database StringDB, the name of the user, and all the information, right, of the connection. Okay, so now we're in StringDB. Let's create the table, the schema. So we have two SQL files. I will provide all these files in a single zip file. So you need to, of course, put these files in a folder, and you know where is located that folder. Right now, I'm inside the folder here locally. So I'm gonna run the schema to create my tables, and then there is a seed SQL file that will populate the tables. It will create information for the tables. So let's get started with the schema. So here, I use the I command to run the schema.sql. It's important to mention that because that's a common error that I have seen throughout the course, and it's the path location. Right now, the path, my path is this one. I'm inside the folder, so that's why I just need to type the name of the file.sql, and that's it. But if your file is somewhere else, I don't know, maybe in the downloads folder, so you need to go to that folder, to find the file, and you need to copy the path. And with single quotes, you will need to paste that here after the \i. You paste the complete path with the file name. Okay, so I run the schema to screen the tables. Now I have the table, but now we need to add the information or the data into our tables, and that information will be created by the seed.sql file. So this file is going to generate just some random information about the readings for the sensors or the devices that we're using. But also here you can use like a CSV file, like with the copy. I think we have done that in the past. So let's run the seed.sql file with seed.sql, and now we're ready. Now we have the information, we have the tables, and we can start working with this database. So we can create some queries if you want to visualize which tables are inside that database. So remember, you can just go to this information. Let's say here you can list the tables using dt, that command, and the name of the schema. So we can use dt, the name of schema stream, and it will show us all the tables that we created. So let's do this. Let's use this command here, the schema dt stream dot star. So it shows that in the schema we have a table with the name alerts. There is another one, dim device, dim location, fact, event, stream. So we can even visualize some of them. You can use an SQL file if you want. You can create an SQL to do all the queries. That's possible, or you can do it directly on your terminal. Something like select, let's see, everything from the schema is a stream dot fact event stream. So I'm missing now something, the semicolon. I'm gonna hit enter on purpose because I want you to be aware that, for example, here you see the name of the database, the equal, and the arrow is an equal sign and the greater sign, right? But if there is something missing, I hit enter. Please notice that the arrow looks different. So now you don't have the equal sign, there is just a hyphen here. It means that you're missing something, expecting something. So if you want, you can complete the sentence, the code, so adding the semicolon, or you can stop the whole thing. You can stop it just by hitting like R, like this, or with Control C. Either way, you can stop the query. So it's important to recognize this difference, because sometimes you might get, like those weird behaviors. So now I'm going to complete my command. So it's going to start showing some information, but it's a long table. So I get some of the readings, with timestamps, and I can keep hitting enter to see more information. But since this is a long table and I didn't add like a limit to my query, you can just hit Control C again to stop, like the visualization of this query. And that's it. So now we can keep working in this one. Okay, so let me show you one more thing before we go to the analysis, is that you can create users. So for example, I can create a user for the students. I can create like one user per student. That's an option, with the password. Or I can create like just a single class user. And of course, you can grant some specific abilities to that user. So for example, that this person can use the schema public, and that person can select, insert, update, delete tables in the public schema. That's so I'm giving some specific possibilities to this user. We can create, for the teams, that's also a possibility. You can, if you want to provide a full capabilities to that user, you can just grant all privileges on a specific database, and that will be enough. Okay, so you can just run. Let's run that command, that script, so we can create the users. Okay, I'm getting an error because they already exist, right? I ran this before, but if this is the first time they are running this SQL, you won't get that error. Again, this is because I already ran this script. So the users, they already exist. That's the idea. Okay, so a couple of things. You can also connect to the server here. If you add new connection, so typically we use just the parameters here, right? But you can go to Azure, browse Azure. So it will identify your subscription, you provide your credentials, and with that information, this is my subscription. With that information, it's going to identify, like the resource group. It's going to identify the location, which server you want to use. I have several, right? So you can pick and it will add it here. The nice thing is that you will be able to visualize the tables here on your local computer. All right. Okay, what else? So once we have created our database and we populated tables, now you can just go over, everything. Remember, same thing as we have done before using Jupyter Notebooks. Now you just need to connect with SQL Alchemy. Right? We can perform just an EDA. So we define our connection, the name of the database, and that's it. With this, we can just start accessing the database. We can start, querying our data, and we can get some specific information about the variables, right, that we have on our database. Okay, so you can start plotting, all the information of the reading values, and you can start your analysis, which is the whole idea. This is just how to create a database, but what really matters then is how to analyze that information and take the data to action. That's the whole purpose of the things that we're doing. All right, I'm going to stop the video for now. I'll see you in our next lecture.